Alright guys, we're going to simplify circuits down. So this is a compound, and we're going to say it's hooked up to let's just say it's a 10 volt power source, battery, whatever. And then it can ask different questions. Like it can ask, well, how much current, right? How much current is in this 2 3 well, here, sorry, I can't count. 1 2 3 ohm resistor. Not ohm, sorry. There's 3 resistors. This one has a resistance of 1 ohm. And I'm putting the variables in the picture. So R1 is 1 ohm, R2 is 2 ohms, and then R3 is 3 ohms. Sorry, those are my silly little ohm looking thing. That's this guy here. It's, if I take my time, I can make it a little better. Um, Might get sloppy as I go faster, but that's the variable for resistance. And then, so what's the best place to start with these? Well, the first thing you want to do is figure out what the heck is the equivalent resistance. You're going to do this every time. What's the total resistance of this thing? Right now I got 3 resistors. It's not helpful. What's the total? I can take a second and think about this. 2 and 3 are in series with each other. I have to go through 2 and 3, or I can go through 1. Well, because I said or, right? 2 and 3 are in series with each other. 1 is in parallel. So to simplify, and I got to do this step at a time. To simplify this down, I can find resistance 2, 3 first. Because those are in series, that's pretty straightforward. R2, 3 is just going to equal 2 plus 3, which equals 5 ohms. So this simplifies down. Instead of having 2 ohm resistors, I have one 5 ohm resistor. Sorry, this picture is going to get messy. Now I have a 5 ohm resistor. So I took care of these. What I did is I found the equivalent resistance and made it 1 resistor. That's 5 ohm. I still have the 1 ohm resistor to deal with. So I'm going to do the same thing, except this time, how do I simplify these guys down? They're in parallel. And then this would give me my equivalent. Now I'm ready to find the equivalent, so I can come back to that. And now this one's going to be R over R equivalent equals 1 over 5 plus 1 over 1. Now I'm going to show you 2 ways to do this. Whatever works for you. And all I'm showing, this is math. At this point, the physics is done. We just got to do some math here to get the equivalent resistance. We're not completely done with the physics, sorry. So you get 1 over R equivalent equals 1 over 5 plus. So we're trying to solve this. I'm just going to show you 2 ways to solve this. 1 over 1 is the same as 5 over 5. I got to get common denominators to add these together. And so what I end up with is 1 over R equivalent equals 6 over 5. Well, R equivalent then would equal, I got to flip them, would equal 5 over 6 ohms, which is you can just type that in a calculator. 5 divided by 6 is 0.83. Oops, I wrote amps. Good lord. Oh, sorry, guys. Ohms. All right, that's the equivalent resistance. That's one way to do it. The other way to do it is you can literally just type in. Hold on, let me write this. 1 over R equivalent. So this is or. You don't have to do both. 1 over 5 is 0.2. 1 over 1 is 1. So I can get 1 over R equivalent equals 1.2 ohm. Yeah, 1.2 ohms. But that's over 1 over R. I need R. I don't want 1 over R. I want R. So then I gotta invert everything. So I get 1 over R. The R goes to the top, 1 goes to the bottom, and then I end up with 1.2 on the bottom. But 1 divided by 1.2 is 0.83. I was gonna say amps again. Ohms. So whatever works. That's just the first step. You don't have to do it both ways. It's an or thing. Whatever makes more. If you like messing with common denominator fraction, that kind of thing, then you can do it the other way, the drawn out way. Or you can just type it in the calculator and let the calculator spit out the answer. All right. The other 2 questions, I'm going to jump to the other slide because I am out of space. The discuss calculating current and power. Let me go to the second slide here. So now I know that the equivalent resistance was 0.83 ohms. And then let's just say I want to know the total current. And then I said the voltage. I had this hooked up to a 10-volt battery. So this is 10 volts. So it's just V equals IR. It's really V equals IR for most of this, well, power's P equals IV, but, so V equals IR. So I know V is 10, I is what I'm looking for, and R is 0.83. So 10 divided by 0.83, I can get a current of around 12 amps. That's total current, though. So we got to be careful here. 12 amps comes into this thing right here. And this is the junction rule. 12 amps comes in, 12 amps has to come out. What current is here? So this is I23 question mark. And which current is here? We got to take a second and we can find that. So this is a parallel circuit. So this branch up here, these guys are getting 10 volts. R1 is also getting 10 volts. So this is what I was saying. It's V equals IR again, but this time we're looking for the current just in those individual resistors. So it doesn't really matter which. Well, let's start with the one since it's by itself. So if this one's getting, oh, and then what's the resistance? R1 is 1 ohm. Oh, I wrote that on the other slide, and then I wrote here. It's up here still. R1 is 1 ohm. I know it's getting 10 volts. So how much current is it getting? So I1's current, again, is V equals IR, but this time we're changing stuff up. I know V is 10. The total current is 12, but that 12 has to split. It's two paths. So it's like you hit two paths. You can go left or you can go right. And I'm doing the bottom path. So I1 has a resistance of 1. So I1 equals 10 amps. So I got 12 amps total. 10 amps, just 10 of the amps went through R1, which only leaves 2 amps for R2 and R3, which is the answer. So then I can do, I'm going to show it to you just because sometimes you don't always see which one to do first. It doesn't really matter which one you do first. This is the other option. Or we could have done R23 has a resistance of 2 plus 3, which is 5 ohms. And then we're looking for I23. That's the question mark. And V is still 10 volts. It's hooked up to the same battery, so it's 10 volts. So you get V equals IR. So you get 10 equals I times 5. So I equals 10 divided by 5, which is 2 amps. So I got 10 amps, 2 amps on this side, 10 amps on this side. So the 12 comes in, 2 amps goes through the top, 10 amps goes through the bottom, and then when they come back out this B side, I'm back to 12. That all checks out. So these have nice little checks. The problems aren't always going to ask you for every single possibility. I think to practice at the beginning, I do ask for almost every single possibility, but that won't be every time. But so you end up with 12. Oh, and then here, why did more ampage go through the bottom resistor? Well, that was only 1 ohm. So it was really low resistance. This was R2 and R3 had a total resistance of 5 ohms. More resistance, you're going to get less current. And then the last little thing they might ask about is power. It's just P equals IV. You're trying to squeeze that in down here. P equals IV. So let's just say I wanted the power through, let's just do P2 equals I2. How much current? So this is the power in this resistor is what we're looking for. How much current is through this resistor? Well, these are in series, so they had the same current, which was 2 amps. How much voltage is R2 getting? That is a trickier question because it's R2 and R3 got 10 volts. So we got to stop for a second. and find, what do we need? V2. We can get V2, and so you're playing with some combination of V equals IR. So let me do a different color. We'll do this pinkish color. So I need to know V2. That's just V equals IR. And so V2 is going to equal the current through 2, which is 2 amps, times the resistance of 2, which was 2. So this thing's going to have a voltage of 4 volts. So then I can come back over here, do 2 times 4, and I get 8 watts. That's how much power that thing's drawing. If you're going to do it for R3, well, we're just going to check this out just so you can see what happens. But if you do it for R3, because I am out of space, but here, we'll just see if we can kind of work this out. There's 2 ways to do it. I know R2 took away 4 volts. So if I had 10 volts, R2 took away 4 volts. That leaves 3 volts for R3. I can check that. I'll just do this real quick. So V3 is going to equal 2 times... It's V equals IR again. Sorry, guys. I'm putting stuff in space I don't really have. V equals IR. The current is still 2. They're in series. They have to have the same current. They're in the same line, so they have to have the same current. The resistance is 3, though. And then 2 times 3 is 6 volts. So there's your 10, right? The R2 took 4 volts. This one took 6 volts. Now the power through R3 is going to be 2 times 6, which is 12 watts. So R3 is going to take more power out of the circuit than R2. And then we can continue that process. Well, actually R1, might as well finish it. Here, we'll keep talking for a second. If you want the power in I1, again, this is just P equals IV. Sorry, guys, I'm writing over stuff. So this is P1. Well, P1, we said, got 10 amps. So it's going to be 10 times the voltage, which is also 10. So this one takes 100 watts. So that one's going to, which means it's 100 joules every second. This one's taking 100 joules every second. P2 is only taking 8 joules every second. And then P3 is only taking... I guess we didn't do that one. Well, anyway, it's taking something. All right, I'm going to stop tormenting you.